In this video, we're going to integrate the integral of x to the fourth over x to the fifth minus 7 multiplied by the natural log of x to the fifth minus 7. So just to be clear, all of this right here, that's your integrand right here. Got the dx at the end here. So there's a couple of ways we could do this. We want to try u sub. We can let u equal to x to the fifth minus 7. So du would equal to 5 x to the fourth dx. And we look at what we have over here. Got x to the fourth over here, 5x to the fourth. This doesn't seem to work. So what about if we let u equal to the natural log of x to the fifth minus 7. Then du would equal to the derivative of the natural log on the right. Formula would be the x to the fifth would go in the denominator, and then we take the derivative, what's in here, and that's 5x to the fourth. And that'll be your dx over here. So notice we have x to the fourth right here over x to the fifth minus 7. So treating this expression here as a product with the dx, and then over here I'm going to divide both sides of this by 5. So that allows me to replace the x to the fourth over x to the fifth minus 7 times dx by du over 5. So come back over here then, and we can set this equal to the integral. Again, this product right here, x to the fourth over x to the fifth minus 7 dx is replaced by du over 5. I'll put the 1/5 over here. And then this expression right here, the natural log, that's your u. So this will be u here. And then we have du. Then we just integrate with respect to u. This will be add 1 to the exponent here. This will give us 2. And divide by that 2. We get this. Plus the constant of integration. And to simplify this, we have u squared at 1/5, and then the 2 and the 5, that'd be u squared over 10 plus the constant of integration. And then we just go back to the original variable. So this is going to equal to, the u is this natural log here, so this will be natural log of x to the fifth minus 7. I could put the square here, or I could just put this whole thing in brackets. Square there, and the 10 down here, plus the constant of integration. And this is one that you could also check your answer by computing the derivative of this expression using your chain rule, and you'll see that it comes out. Now you could also do this by integration by parts, and you would get the same answer that I have here. And I'm going to go ahead and set this up in case you want to watch the rest of the video. But this is it. This is the easy way here with this U-substitution. But in case you don't see this and you do it by integration by parts, this is what you can do. Okay, there's the answer. And this to the fifth power here. The natural log of x to the fifth minus 7 over 10. So I'm going to set it up. I'm going to set it up using integration by parts. Integration by parts, I'm looking something I can take the derivative of and something I can integrate. So I can integrate this one. I can take the derivative of this one also. This one, the integral would be a little bit difficult here, so I'm going to let u equal to this. So I get u will equal to ln of x to the fifth minus 7. I'm taking the derivative of that. And I pick my dv. For my dv, I pick something I can integrate. So I'm going to select the rational expression x to the fourth over x to the fifth minus 7. So then v would equal to, if I integrate this, on the side over here, I'll just say this is u equal to, and this is a different u than this one over here. So I could call this one u1, but I'm just going to call it u, and say that's equal to x to the fifth minus 7. So du would equal to 5 derivative of x to the fifth, 5x to the fourth, dx. So I'll put the dx over here for this one. So this would be u, this would be u, and then if I divide both sides by 5, x to the fourth dx will be replaced by du. So the 1/5 would be over here then. And then I'd have the integral of 1 over u, which is natural log of x to the fifth minus 7. And that's my setup for integration by parts. So then this would then equal to the formula for integration by parts starts off the answer. U times v will give me the first part of the answer. So that's u, and this is v over here. So I'll multiply these two out. So this will be 1/5 here. Put the 1/5 here. And it's ln and ln have the same expression. So this will be ln of x to the fifth minus 7. And multiplying two quantities the same. So I'm just going to write this in brackets here. And that'll be squared. And then second part of the formula is a minus here, and then it's the integral of v. And then over here, I need to find my du. So du is equal to, derivative of this will be x to the fifth goes in the denominator, so it'll be x to the fifth minus 7. And in the numerator, it's the derivative of this x to the fifth minus 7, which is 5 x to the fourth dx. Okay, so now for this part here, it's v, which is right here. V is right here. And then it's times du. So what I'm going to put in here is going to be v right there, and du, which is 5x to the fourth over x to the fifth minus 7 dx. So notice here the 5 and the 5 here are going to cancel out. So that's going to give me x to the fourth over x to the fifth minus 7. And then it's ln again. ln of x to the fifth minus 7. Now notice the original integral right here, x to the fourth over x to the fifth minus 7, ln of x to the fifth minus 7, that repeated. So instead of messing with this integral here, since this is the same thing as this one right here, we simply bring that over to the other side. And let me just make it, I don't have to write this again, let me just do this. So here's what I'm going to do. I'm going to add this integral to both sides. So it's going to cancel it on this side and add it to the other side. That'd make this a 2 over here. So adding this integral to both sides cancels it here. And then I add it to the other side, I get a 2 there. Well, you can see this clearly. And then now what we have is this. I have 2 times this integral is equal to this integral. And I want to solve for this integral here. So what I do is I divide both sides by 2. So if I divide this side by 2, cancels that, so it gives me 1, and you divide 1/5 by 2, that's the same thing as multiplying by 1/2. So 1/2 times 1/5 is 1/10, and I'll just put the 10 over here under the denominator, and of course the constant of integration. And that's the same answer I got using the standard U-substitution. But this one's a little bit more involved, but it gives me the same answer. Thanks for watching. We'll see you next time.